Hello, my name is Swami Kachari and this is my task 2 for the Sparks Foundation, which is prediction using unsupervised ML. Uh, uh, from the IRIS dataset, we have to predict the optimum number of clusters and represent it visually. So let's go to R. So we need these two libraries, which are ggplot2 and cluster, and we need this for to have a look at the plots. So first we can do is we can load the data, then we can do head of the data to have a quick look at the data set, which is we have id, sepal length cm, sepal width cm, petal length cm, petal width cm, and species. So what we can do is um, we can have a quick we can visualize the data quickly using ggplot2 by having the data, then asterisks, petal and cm in the x-axis and petal and cm in the y-axis, and then we can pass quickly geom dot point, which will give a scatter plot, and we have given the color here. So we have the plot here. We can see that iris certosa is distinct alone away from the iris versicolor and virginica. Here we can see that in case of iris versicolor and iris virginica, we have some disturbance where these are, joining right here at this intersection point. So next, what we can do here is that we can build a model. We are setting the seed, which is equal to set seed 128, so that you get the same result as mine. Then we are creating a variable called data cluster and passing our k-means data, uh, and then we are selecting all the rows, but the column 2 to 4, because we don't need the id column here. We just need 1 2 3 4 4 rows, and we can give an additional argument as the start, which is 20, which will be the number of starts. And then what we can do is we can actually print the data cluster, where we get a number of uh, statistics like the three clusters of the size, you know, cluster means and clustering vector, and available components such as cluster centers, dots within as dots within between size, etc. Now what we can do is we can actually plot the table where we can use data clusters and use this cluster and then data species, data idea of the table. So it has actually predicted. We can actually see in case here we have iris certus, iris versicolor, and iris virginica. So it has correctly predicted the number 3 cluster, which is 50. But in case of iris versicolor, there is some mm, noise, and for the first cluster, uh, there is the maximum number is iris virginica. For the second, it is iris versicolor, and for the third, it is iris certosa. So now what we can do is we can use this library, which we already installed, cluster, to use this function called clustplot data cluster, compare this to our original data, and we can run this. So we get this. Sorry, I think I missed another. Okay, so if we run this, we get this, which if we zoom that ice, as we get that iris sartosa is actually alone away from these two. Here we have iris virginica and versicolor, which are intersecting at this point, and these are two components. As we can see that these components explain 93.41% of the point variability. This is good because we have limited number of uh, components like component one. If there are like multiple, then we can surely use ggplot to plot those out. So here is the visual of the cluster plot, and thank you.